Yep, said it before and I'll say it again. Life moves pretty fast. If you don't stop and open your mail once in a while, you can miss it. Hi, welcome to Mailbag Monday again. I have been absolutely inundated with mail. I've actually reached double digits since the last time I cracked 10 items. So anyway, there's a whole bunch of stuff to open. I won't get through them all. I'll just pick a few. And sorry if you can see your bit of mail in the video there and I don't do it, I will get around to it. So I've got a couple of Aussie ones here. So let's check them out. It's from Perth and it's from EEVblog at HEWBALL.com.au. So EEVblog, thank you. I don't know your name, but check out the website. There's no other details on here, but it is Australian. So let's check it out. Get my knife here, trusty Victorinox Mini Champ, and let's crack this sucker open. PLA. What does that mean? It's probably just already written on there. I'm going to rip this. Oh, hey, what do we got? IMPLA. Brilliant. Microcurrent cases. A multitude of, what is the collective term for microcurrent cases or 3D printed objects? I don't know, but they all are in different types of PLA. Oops, there's something else in here. Aha! That was stuck on the inside there, thinking I wouldn't see it. No, I see it all. Printable.com. There you go, printbl.com. So that's, I assume, his website. Got to check it out. And if you haven't seen this before, Charles Pax at MakerBot actually designed this 3D printable case. You can download it from the Thingiverse website, and it's a case for my microcurrent, and it is a little bit tight in some places depending on that, but it's designed to fit the board on there like that, and it's got the name on the side there raised out from the side of the case, and it's neat. And this is a whole bunch of different coloured material. Wow, must have taken, there's been no raft on that. It's been printed without a raft. You can see how smooth that is, but this is printed with a whole bunch of different material. IMPLA, that's the sample we got. I assume it's, that's a 3mm stuff or something. It's not the standard 1.75, and a whole bunch of different colours. It really looks quite neat. They almost look edible. I like it. And I checked out the website printable.com, and I found out a bit of info about the IMPLA. Did a bit of a Google search, and IM stands for Impact Modified PLA. It's like your regular PLA stuff you can get for your 3D printers, but it's impact modified in some way, shape or form. I'm not exactly sure of the process, but it's supposed to be more durable and more like a thermoplastic, a proper thermoplastic you would get, an impact resistant thermoplastic you get in high quality products. And apparently you can use this stuff to now 3D print on your 3D printer. Brilliant. Costs about 48 bucks per kilo spool. It's available in this 3mm stuff. I'm not sure if it's available in smaller diameters, but there you go. You learn something new every day. A new type of material. Brilliant. And I assume, well, that's what this one's printed out of. And I think I can feel the differences. This does feel like a more traditional high quality thermoplastic than this. Seems a bit more brittle. This seems like it would, really shatter if you took a hammer to it or something like that. Yeah, I probably should take a hammer to it, but I won't. These are nice microcurrent cases, but there you go. Google it. Impact Modified PLA. So thank you very much, nameless person who sent that in. There was no name on the website at all. And this next one here comes from, ta-da, Gulagum Electronics. I'm sure if you Google that, you'll get the website in Macquarie Fields here in New South Wales, in Sydney. They're in the southwest of Sydney. And let's crack it open. So thank you very much. Didn't put a name on there, just Gulagum Electronics. And we will slice this sucker open and see what we get. What do we got? We have a letter. Do you like letters? Oh man. Baseline, mid-range, pick, training and development board. We have another pick. Oh, hey, this looks fun little breadboard on there. Oh, let's check out the letter first. Hi Dave, don't know if you've ever come across my Gulagum pick assembler and C tutorials. No, I haven't, but everyone should check it out, gulagum.com.au. They seem to be popular and a lot of people have told me that they have found them useful. Excellent. I've recently developed a training board to go off my pick tutorials. The idea is that comes with everything you need to complete all the baseline and mid-range lessons. It's not intended to be a general development board, but when people finish the tutorials, they don't need to throw the board away. Still functions as a nice, here we go. It costs 89 bucks fully assembled or 69 as a kit, which is why it's through hole. Excellent. If you want to save the 20 bucks. Thank you very much, Dave. There you go. Great video blog. Thank you very much. Let's take a look at this. We've got our CD with baseline construction and operating guides. I assume that's what we got printed out. And we have some additional parts for the tutorials. Just a couple of extra chips on there. Yeah, there's a pick on there. And there's a couple of microchip. Oh, they're the 10F ones. Okay. This pick development board is designed as a training environment specifically for use with the introductory Gulagum baseline and mid-range pick tutorials. Okay. All right. So, what else is... Oh, nice documentation. Everyone knows I'm a big fan of nice documentation. I like that. A lot of effort gone into that to explain all aspects of the board. Brilliant. All the jumpers, explains what all the jumpers do. Brilliant. Baseline assembler, and it looks like a chart, lessons, examples. So they've got a whole bunch of, take you through all the low and mid-range lessons. Oh, and we've got some schematics. Excellent. Let's take a look at the hardware. A funky looking board with a really neat looking see-through. I've seen photos of these, but that is a see-through breadboard. That's rather neat. I like that. Never actually seen one in person before, but you can see the contacts in there. Nice, I really like that idea. And if we take a look at the board here, we've got our in-circuit serial programmer ICSP interface up there. That goes to the Pick Kit 2 or the Pick Kit 3. I presume you can also buy that from Gulagum Electronics, and two regular machine pin sockets here. They're not ZIF type with the lever, which would have been nice, but considering that you're using the in-circuit serial programmer, it doesn't really matter. So you can whack some of your chips in here, which you get, and run all the examples. They go down to these headers here, and then you can jumper those over into here. So that's why they presumably supply us some solid core wire here. Would have been nice if they were pre-cut or something like that, but heck, yeah, that's rather neat. We've got a whole bunch of LEDs you can drive, and we've got a buzzer, we've got a couple of pots, and we've got other stuff and jumpers. That's a rather neat 7-seg display, of course, powered from an external 3 or 6 volt, or presumably you could also power it directly from the ICSP port as well. If you're in the market for one of these, I won't power it up and play around with the software. That'll take like forever. One thing I've always wanted to see if I could do is experiment with taking the base off the breadboard and exposing the contacts on the bottom and actually reflow soldering them directly onto pads on a board, so you wouldn't have to jump over like this from a header connector over to the main board. You could actually access the individual pins on the breadboard directly, and I think there might have been a few people who've experimented doing that. So I'm not sure how successful you'd ultimately be in doing that. Of course, you couldn't inspect any of the joints. It'd be like a BGA. You'd have to x-ray the thing to check if your solder joints are okay, but that'd be, I think, neat if you were able to get a breadboard like this that actually reflow soldered directly onto the main board without having the jumpers. I just think that'd be neat. And there's a few options on here. There's a couple of oscillator options, 32 kilohertz, 4 megahertz. You can select all those with jumpers. We've got some photo cells there and over here, and we can adjust a variable frequency as well, input. One interesting thing I just noticed with this board, if you take a look at the power input here, this DC jack, it's got a series diode protection in there, but it goes what looks like down to the ground plane, but it's not. This plane on the top here is actually your positive rail, and that goes over and connects to pin 2 of your in-circuit serial programmer. And the bottom of the board is all ground, and that's connected through there to pin 3 of the IC SP connector. So that's effectively being used, not that it matters on a board like this, but it just means that the top and bottom layers on a 2-layer board like this act as one big bypass capacitor effectively. The other thing I like about this is that no effort has been made to make it small. You know, it's big. You can solder this if you get the kit, and you can hack things, you can wire stuff. It's just, you know, it's not built down to some tiny little board. It's nice and big where you can access everything. And thumbs up for any project that uses a 555 timer. Love it. And I just checked Dave's website very quickly at goolagum.com.au, and you can download all of the tutorials, which are presumably on here, so you can have a scratch and sniff at all the documentation, all the tutorials and the source code before you decide to buy the board. And that's the issue. I mean, there's so many of these PIC development boards out there, countless ones, and it really all comes down to what one is the most suitable for you, and it comes down to not really the hardware, it comes down to the software and the documentation. So go on there, download the documentation. If it thinks, you know, if it looks like a really good one which you can understand and it makes sense, then you buy the board. If not, you go look at someone else's. That's how these boards work, and I think the tutorials look quite good for this one. So thank you very much, Dave. That was interesting. If you're after these sort of baseline, low to baseline, mid-range PIC development boards, check out Goolagum Electronics. Next up, we've got one from Charlie Peccia from Uruguay. Awesome. I don't think we've had one from Uruguay before. Montevideo. Go figure. And on the front here, we've got some lovely stamps. Check these out. They're like you know, gum nut babies like we have here in Australia, or something like that. They're little creatures inside nuts. So I can't read that. I don't know what that says. I'm sure all of our Uruguayan, if that's the correct term, viewers can tell us all about that. Neat. Well, let's open it up and see what we have in here. Don't need a knife for this one. What do we got here, Charlie? We've got a padded bag inside. Oh, he's returned it. Oh, it's my microcurrent. He's returned a microcurrent. Why has he returned a microcurrent? Here we go. This is one for your collection. I hope it is useful, but first of all, don't turn it on, take it apart. Tool included. Regards, thank you very much. What have you sent? No. I don't think it's a microcurrent. Doesn't have the look and feel of a microcurrent, but this is the microcurrent that I sent to him. So obviously Charlie has purchased one of my microcurrents before and sent it back in the same bag. I like it. So what do we got here? Oh, I didn't even realize. I just cut that. It's a flat flex cable ribbon. Oops. Oh man, that's great. I love it. Flat flex cable. There we go. Excellent. Nice work. Didn't even notice. Just, oh, it's a little analog multimeter. Oh, what a heap of crap. Look at that. As much as I love analog multimeters, oh my goodness, That is the one hung low of analog multimeters. Oh my. Oh, what an absolute shocker. I mean, it doesn't even have a brand on there, does it? It's just, is it going to fall apart if I take the rubber band off? Oh my. That's an absolute shocker. Oh, man. Would you measure 1,000 volts AC with this thing? Oy. I don't know. Let's get our screwdriver out here. Ta-da! And let's open this sucker up. Oh boy. Oh. What can I say? A picture tells 1,000 words. Crusty meter movement in there. Just a couple of contacts for our single AA for the ohms range, and a calibration pot in quote marks. You've got your ohms. Oh no, sorry. Oh, no, sorry. That is the ohms adjust. There you go. Oh man. Oh, this is so embarrassing. It really is. This is terrible, Muriel. My Australian viewers will. Oh, missed one. Oh, this is shocking, really. And there'll be absolutely bugger all on the bottom. There we go. It's just the switch contacts, and that's it. Look at the little probe posts, the little 2mm ones, and that's the probe, by the way. Oh man, that is so crusty. Look at that. They haven't even bothered to put a point on it. Yeah, why bother on a multimeter like this? Oh, that is this the crappiest multimeter possible? Quite possibly. I think it's worse than the one hung low $2 digital ones. And if we have a look at the sensitivity of this thing, 2K ohms per volt. Oh man, that's as bad as you can get. You, of course, you invert 2K on the calculator there for 1 volt, and you get 500 microamps full scale deflection for the meter movement. So curiously, I might actually just hook this up to my constant current source and put in 500 microamps and see if we get full scale deflection. Imagine trying to measure anything high voltage with this thing. I mean, this trace comes over here. This is from one of the input jacks. Comes over here right next to the other input jack. Take a look at the creepage distance. So the traces are on the other side of the board there, but the creepage distance there is just absolutely nothing. And right up here too, because this trace extends up here and it goes right. That's even worse. Look at that. Oh man. Oh. Are there any words to explain the crappiness of this? I can't believe they even sell this pile of junk. And although this steaming pile of dog turd doesn't deserve it, I will hook it up to my Keithley 225 current source. So let's check it out. All right, I'm on the 500 microamp full scale deflection range here. And if beginners out there, if you haven't ever used an analog multimeter before, we're on basically 500, so 500 microamps full scale deflection here. So you'd use the 50 there, you just pretend that there's an extra 0 in there. So that's 500, 400, 300, 200, 100, and it should, the meter needle should be smack on that mark there, but it's not. It's reading high, it's reading 145. That's why there's supposedly a little mirror in there so you can eliminate parallax error. You can probably see so you can read it at the correct angle, and man, it's just a steaming pile of dog turd. What I'm going to do is I'm going to zero the thing here. So let's, no current going in, so I'm going to zero it at this angle. Oh, you can't even zero this heap of pile of crap for that particular angle. Nah, it's just garbage. Absolute garbage. The 500 microamps full scale deflection. Oh, what? Fail. Hello? I'm feeding 500 microamps into that. It's supposed to go to full scale deflection. It's probably hitting, is it hitting something in there? No. Oh man, Words cannot explain how much of a heap of crap this thing is. Urgh! So thank you very much, Charlie, for this wonderful bit of high quality test equipment. And I know what everyone wants me to do with it, and I think you'll get some satisfaction in the near future. Not in this video, but yeah, I got something planned for this sucker. You'll see. And the next cab off the rank here, we have Lei Chi Hung. Thank you very much, Lei Chi, if I'm pronouncing that correctly, from Malaysia. Penang in Malaysia. Great, let's check it out. And if we read the custom form, 2 toys. So, what sort of toys do we have here? We will find out shortly, such as... let's rip it. Let's rip it. Oh, sorry, forgot to look at the Malaysian stamps. Ah, lovely. We have some birds. We have a bird. Excellent. I can't read that on the screen here, sorry. But anyway, that's lovely. We've got some trees and some flora and fauna. I like it. Anyway, here we go. It's a Hewlett-Packard box, HP, but I'm sure it is reused. Nobody sends me original stuff. It's all used. Now, let's have a look. 2 toys. What sort of toys? Bubble wrap, bubble wrap. Oh, hey. Oh, here we go. We've got one of these nice little, it's like one of these attenuator boxes. Hey, hello. This is, I was expecting farting novelty toys, but no, we've got some good stuff in here. There's a note. Let's read Lei Chi's letter here. It's, "Hi Dave, I enjoy your blog so much and I think I'm going to send you something to show to all viewers. Thank you very much." That's what this mailbag segment is designed for. Recently I've been working on a small project that involves PCB assembly testing for production. We need to perform simple measurements to different test points on the PCB assembly. After SMT mounting, all off-the-shaft passive probes are good and inexpensive, but I found they are not good for my production as they are mainly designed for debug and troubleshooting. I have a 2-channel 70 meg scope and I need to measure no more than 8 points on the assembly. I use a HP/Agilent 35970A together with a RF module to switch between test points. So he effectively uses an 8-channel scope for his production measurements there. That's not enough because off-the-shelf passive probe utilizes a special high Z, approximately 200 ohms and lossy, 150 ohms per meter resistance coax, which will definitely cause unwanted distortion to my measurement if I try and mux them on the Agilent muxer there. Encloses do-it-yourself passive probes that I've built for my production testing. I do not claim it's my invention because it's basically an embodiment of a US patent. Excellent. We can Google that. I'm sure I will not repeat the theory. Here is the summary. It consists of 2 parts, probe end, scope end. Mistakes? We'll check it out. Let's have, here we go. Schematic. This is what we want. Here we go. This is a passive probe, clearly optimized for some tweaked, for some sort of step response, some sort of response into the scope probe with the coax. Neat. Design rules. Here we go. We can go through it. I'm sure if you want to simulate that, you could go to your heart's content. That would be most interesting stuff, simulating and even, of course, building up and measuring these kind of passive probes. Uses RG174 coax. It's recommended because it's small and bend radius and it's commonly available. So when combined, so this is nice. It talks about which component values up here, what their job does. Combines with the oscilloscope's 1 meg input. It gives a certain 1 to 10 reduction ratio for the low frequency band. High probe resistance, blah, blah, blah. Great. I like it. What else have we got here? Cable length configuration. All right, that's what he's using. It's optimized for a 1.4 meter cable length with a cable capacitance of 140 picofarad, and they're the values you tweak in your circuit to match your particular coax that you're using. There's A lot of art that goes into these passive probes. Oh, here we go. It optimizes the step response. There we go. It's chosen this one. 22 ohms is the optimal value. Any value above that, it reduces the overshoot or increases the overshoot. So clearly, hand tweaked that value for this particular circuit and this coax. Hey, check this out. We've got components taped onto the circuit for our kit. There's our little kit. Got some boards. Take a look at that, and that we can build one up. And here's the pre-built one, and it looks nice. It's amazing what some heat shrink can do just to make it look reasonably professional. Got some easy hooks on the end for connecting directly into this circuit. There's our circuit on the PCB down in there. We've got a little matching board in there to do that, and the RG174 coax to the BNC. It's given me another one here, which allows me to build up another one with this little kit. Nice, I like it. So this part of the circuit, this board here, is this input probe circuitry up here mounted on that little board directly into the easy hooks. Then it goes into the coax, which is our big coax here, and this connects into the this end of our circuitry, which connects into the scope. So our passive probe plugs into there, and then this plugs into the scope, and that contains the rest of our matching circuitry down in there. Neat. So let's crack that open and have a look inside. Bingo, we crack that open, and oh, there we go. It's nice. It's mounted 45-degree angle like that, so you can solder the pins directly from the ground pin there and the input pin. So that's a really great layout there. I love it. And I love these little Pomona boxes. He's actually provided me a spare one, and there it is, Pomona 3752 aluminium die-cast box, and you get all the connectors built in. Great for doing, as I said, those little attenuators, or like an RF attenuator, or a little trap filter or something like that. Really handy little boxes to have a few of these lying around. I highly recommend them. I don't think they're particularly cheap, but I've built many a thing into these style boxes. You can get them in various sizes, but this is a tiny little one. And I can't really let this slide without checking out his handiwork inside this. Only one way to get in there. There you go. Isn't that beautiful construction there? I really love it. And clearly those slots in there are designed for maybe wrapping some wire around or attaching other stuff too. I like it. It's left out a square on the ground plane there. That's probably to lower the capacitance to the ground plane, because if you just flood fill that board completely with ground plane, then you're going to get capacitance between the ground plane through your FR4, which is a dielectric material. Of course, everything's a dielectric material, even air, and can cause stray capacitance and ruin your day, especially with high frequency stuff. So beautiful little construction there. Thumbs up. I like that. Really robust. Beautiful. So thank you very much, Lei Chi, for sending that in. That's most interesting passive, a custom passive probe there, and I'll leave it up to the viewer to simulate and check out this circuit and have a play around with it. And we'll call this the last one for today. And remember, if you want to send stuff in, send it to That Crazy Aussie Bloke, PO Box 7949, Borkham Hills, BC 2153, Australia, not Austria. So let's take a look. It is from Todd. Hey, Todd Harrison from Todd Fun. He's a fellow blogger. He's also got a YouTube channel. He's from Mesa, Arizona. I've been to Arizona. I didn't get down to Mesa, which is near Phoenix, I believe, which is south. I went to Flagstaff. So I went to Meteor Crater there, and I remember I was driving along and we were driving along the road headed to Meteor Crater, and we saw a sign, Winslow, Arizona coming up. You know, tune your radio to, you know, 88 point something to get the info. So we tuned in, see what's at Winslow, Arizona. You know, this, you know, the Eagles song, and sure enough, they had the girl in the flatbed Ford. That was pretty much the only thing that they were trying to entice people there with, I think. So we gave Winslow, Arizona a miss, but we never got down to Phoenix. Now, I'm not sure what's going on with the Indianapolis 500, because even though I'm not a Yank, I'm pretty darn sure the Indianapolis 500 is held in Indiana and not Arizona. Go figure. But, ta-da, we have Monument Valley. Of course, I've been to Monument Valley. Fantastic. Love it. Cannot recommend it highly enough. Awesome. So, thank you very much, Todd from Todd Fun, and I can barely make that out. I think it says meter at $99 US. It's sort of the size and weight of a meter. So, I don't know. Let's open it up. And if you haven't checked out Todd's YouTube channel, by all means do. He's a fellow video blogger, and has a website as well at toddfun.com, but also has a YouTube channel. Ta-da! Here we go, we've got a letter. Oh, there you go. Awesome. Chinese market Fluke 17B for your collection, and Tuesday Teardown. Many fans, including myself, would love to see a full product review. Someday order this in the USA from Deal Extreme for $99.60 with free shipping, and it took 47 days for delivery. Are you kidding? I didn't care for the way it was shipped in a simple unpadded bag. Ooh, yeah, it's not true RMS, other shortcomings, but yeah, it's probably, from all I've heard about it, and I have seen photos inside it, it's not a bad meter for 99, you know, for under $100. And by the way, people ask, yes, it is a genuine Fluke, but it's only for the Asia Pacific market. You can only buy it in, well, Asia market. It's not sold here in Australia either, so it's not in the Pacific region, but it is actually a genuine Fluke. And there you go, it even tells you not for sale outside of China. So warranty void if sold outside of China. So, you know, you buy this thing, you get absolutely no warranty. It's not built to, I don't believe it's built to, you know, the same exacting standards as a proper Fluke, where they give you, you know, lifetime warranty, but it certainly is not a bad meter at all. Look at the, from what I've heard, and that feels pretty solid. It reminds me of, you can see the roots in the old, what was it, the Fluke 19, oh, I can't remember. I think it was the 19 one that they originally started the made in China thing with. Of course, this is not made in the US. It's made in China. That would look like pretty quick auto ranging there. Do you get the standard Fluke probes? Let's have a look. So this is great. Thanks, Todd. This is awesome. I have actually been meaning to get one, because quite a lot of people have asked to actually see a review of it. Yeah, they're the Sharp, they're the TL, I'm not sure what the, I think TL74 I think is the standard model number Fluke probes. Anyway, they are 1000 volts. Oh, Cat, no. Look at that, Cat 1. Are you kidding me? They've got to be kidding, right? 1000 volts, Cat 1. 10 amp. Are you, what? Cat 1? Are you got to be joking. Oh man. Oh, unbelievable. Anyway, they do feel reasonable quality, not as good as the regular Fluke 19. Yeah, that's it. There you go. FLK 19CF. Fluke, they've still got the old Fluke 19 model number. That was the first, probably, if memory serves me correctly, like 10, maybe even 11 or 12 years ago, the Fluke 19 came out. It was Fluke's first experiment getting a meter manufactured in, designed and manufactured in China, and it failed. It sold really well apparently, but it failed dismally. Almost every one of the Fluke 19s on the market, you know, failed terribly. But we do have another. Looks like a genuine Fluke temperature probe. Let me compare it to my good one, which came with my high-end Flukes. Now the one on the left here is my genuine one. As you can see, it uses a lighter coloured brown cable there, as opposed to this darker colour one. So apart from that, it's actually rather hard to tell the difference between these two temperature probes. I don't know. I think I'd trust the higher end one better. So anyway, it does feel like a quality bit of kit. It does feel like a quality Fluke meter, and you know, it passes all their, you know, standards and stuff like that. I'm sure it's got microamp range. It defaults to DC. Brilliant. Why can't the bloody Fluke 87 default to DC instead of bloody AC? God, it's annoying. And it's got capacitance range. What's the minimum? 10 picofarads minimum resolution there. That's, you know, yeah, it's par for the course. But the range switch feels like a quality Fluke. This is not going to be a proper review. If we have a look here, it uses 2 AA's instead of the more traditional 9 volts. So let's crack this thing open, and it does feel pretty rugged. I really like it. Not a huge, you know, there's some protection in the holder. It's not the world's thickest or best holder, but looks like that feels like a metal threaded in. You can easily lose that. It's not like captive with the how does that work? Hang on. How does that? Oh geez, it's all a bit dodgy. Anyway, some grease on there. So that's a step forward for those who actually prefer the AA's. Most likely it won't have the high voltage ohms output, so that's okay, that just slides in there and awkwardly sort of lifts out. Don't really like that, but hey, it's, you know, it's not too bad. I think this one's probably going to perform pretty darn well on the low end of things in the sub $100 category. And yeah, you know, you've got to wonder why Fluke don't bother to market this anywhere else. Is there something that, you know, they're not that proud of it? They just, you know, making money out of it on the Chinese market or whatever? Who knows? I don't know. Anyway, let's go to and continuity. It's not the latch-in type, and it's not very loud at all. So, but it is instant, but it's, hang on, let me put the mic up to that. There you go. It's not that great. No, these probes don't seem to be the best quality tips on them. I might try and get a zoom on that. Now on the top here is the Fluke 17 probe, and on the bottom is one of the new Fluke TL175 probes, and I'm not sure if you can see it, but you can see the marks on there. It's not nearly as smooth and polished as a proper high quality Fluke probe. So I think that, you know, these are really built down to the lowest possible cost, and I can't believe it. Cat 1. Are you kidding me? So I'm surprised Fluke would actually put their name on a multimeter where they're only supplying Cat 1 rated probes, even if it is, you know, they're Chinese manufactured, Chinese branded meter only sold in China. I don't care. That's unacceptable. Even your cheapest of cheap multimeters at least come with, like, you know, a Cat 2 or Cat 3 rated probe. That's just silly. Yeah, I mean, these might be 1000 volt rated, but that's 1000 volt Cat 1, which means it's designed for low energy. In theory, technically, you shouldn't even be probing a standard main socket with these things, because that is a high energy source. It's just unacceptable. Grrr. As for the auto ranging on the resistance mode, let's give it a go. A little bit on the lethargic side, but not too bad. Now, one thing that's a bit deceptive here is the hold. That is not the Fluke, the patented Fluke auto touch hold. It is just a regular crappy multimeter hold where you press the hold button and it holds the reading. It doesn't, you know, do the auto touch hold thing. Oh man. The other thing I notice on this, it's got no backlight at all. The yellow one there is only designed to you know, toggle between the various modes. That's it. One thing I find rather hilarious, patent pending. Why? Why would you want to patent Chinese multimeter? Give me a break. And if you have a look at the input jacks here, Cat 1, 1000 volts, but it is actually Cat 2 rated 600 volts. So, you know, not that great, really. And if I hook it up quickly to my DC voltage standard, got it set for 3 volts, and I'm measuring 2.993. Not spot on, but certainly well within the 0.5% spec. And if I take that down, once again, this is supposed to be spot on 1 volt. And if I take it up a range, there we go, switch to there, that's supposedly 5 volts. So it's spot on. Yeah, a couple of least significant digits out there, but not a huge deal. Let's take it to millivolts. And I don't like how the display blanks like that as you move it. Look, that's a bit disconcerting. Anyway, that's supposedly 100 millivolts, and it's still within spec, of course, but yeah, you know. And if I plug in my resistance standard here, 1K, it's within spec, at least. Still easily within spec. Oh no, color codes are back to front. Oh, the electrons won't know what to do. There we go, spot on at 10K, but once again, sample size of 1. Whoop-de-doo. So although this is not a review, my initial, you know, first 5-minute impression of this thing, haven't opened it up yet. We'll certainly leave that for a teardown. I don't know, when, you know, it's like $100 delivered or something like that. I think to Australia it's slightly over 100 delivered. Maybe you can get it under. I don't know, I haven't checked, but yeah, I don't know. It's more of a $50 class instrument, really. I mean, it's not even Cat 3 rated, doesn't have a backlight, and you know, it feels rugged enough. It feels like, just as a general knockabout basic, you know, volt ohm meter with some basic capacitance, then, you know, it's probably going to do the job. But I think there's almost certainly better value elsewhere, even in like the cheap brands like Unity or something like that, perhaps. So yeah, at this stage I'm a bit confused as to why you would buy a cheap ass Fluke like this. It's not entirely cheap ass. I mean, you know, it's still, you know, Todd paid pretty much $100 for this thing, and you don't get any of the Fluke goodness. You don't get the touch hold. We haven't looked inside it yet. I assume it's a reasonable build quality, but you don't get the proper, nice, super reliable, you can bet your life on Fluke probes. You get these cheapy Cat ones. Don't believe it. You don't even get a backlight on the thing. It's, I don't know. I don't know why they bothered. Anyway, thanks, Todd. We'll certainly hear and see more about this in the future. So thank you very much, Todd. Please check out toddfun.com. He's got a blog as well. So I hope you enjoyed Mailbag. If you like the segment, please give it a thumbs up. Catch you next time. You're still here? It's over. Go home. Go.